Hello and welcome to High Voltage Engineering. We are talking about the measurement of high AC and impulse voltages. Previously we have seen DC voltages. Now we'll be looking for the AC voltage measurements. So the topics here is that there are several topics which we are going to cover here. One is series impedance voltmeters. Then we have a capacitance potential dividers and capacitance voltage transformers. Potential transformers of magnetic type. Then we'll talk about electrostatic voltmeters. We'll talk about peak reading AC voltmeters, followed by spark gaps for measurement of high DC, AC and impulse voltage that are peak values. Then we'll talk about potential dividers for impulse voltage measurements, followed by peak reading voltmeters for impulse voltages. So we'll continue with the first one. Now we'll talk about the series impedance voltmeters. So here we are talking about the impedance. Remember, we are talking about the AC system. In the AC system, we have both the effects of inductance and capacitance. So for power frequency AC measurement, the series impedance may be a pure resistance or a reactance. Since the resistance involves power loss, often a capacitor is preferred as a series reactance. So we have in order to avoid the power loss resistance, a capacitor is used. You can see the schematic diagram of the series impedance voltmeters. Moreover, for high resistances, the variation of resistance with temperature is a problem, and the residual inductance of the resistance gives rise to an impedance different from its ohmic resistance. So we have a schematic diagram of this impedance voltmeter, which has resistance and with a residual inductance and a residual capacitance. So the total current through the voltmeter is given by I equal to dq dt. That is nothing but V dc dt plus C dV dt. The similar expression we have seen in the previous class. Now in this series impedance voltmeters, we have different variation. One of them is a series capacitance voltmeter. Here we have this voltmeter with a series capacitance. The voltmeter has a protective gap. Okay, so this protection is provided for the voltmeter in case there is a problem with the series capacitance. The current in the capacitance is given by J omega CV. The resultant RMS current is given in terms of omega C V1 square plus 4V2 square and so on, depending on the different voltage levels. Okay. Now we come to capacitance potential dividers and capacitance voltage transformers. On the right hand side, you can see the capacitance potential dividers schematic diagram. So there are certain points in this capacitance potential dividers and capacitance voltage transformers. The error due to the harmonic voltage can be eliminated by the use of capacitive voltage dividers with an electrostatic voltmeter or a high impedance meter such as a TVM. If the meter is connected through a long cable, its capacitance has to be taken into account in calibration. Usually a standard compressed air or gas capacitor is used, as C1 and C2 may be any large capacitance like mica, paper or any low loss capacitor. C1 is a 3-terminal capacitor and is connected to C2 through a shielded cable. and C2 is completely shielded in a box to avoid stray capacitance. So you can see this capacitor C1, C2 and C3 C1, C2, how these are placed in the schematic diagram, and the applied voltage formula is given below. Now in the capacitance potential dividers and capacitance voltage transformers, we'll talk about now the capacitance voltage transformers. Previously we were talking about capacitance voltage dividers. Now in contrast to the simple capacitance divider, which requires a high impedance meters like a TVM or an electrostatic voltmeter, a capacitor voltage transformer, in short CVT, can be connected to a low impedance device like a wattmeter pressure coil or a relay coil. So we are not directly tapping in the voltage across the capacitor, rather we are using a voltage transformer to read the voltage, to read the AC voltage. Previously what we have seen that in case of just as the DC, we have a series capacitor here to measure the AC voltage, to make a potential divider, and then we can from one capacitor we can read the voltage. But here what we are doing is that we in this capacitor voltage transformer or CVT, we are actually tapping the voltage through a transformer, which makes the low voltage appear on the secondary side of the transformer, and normal measuring instruments can be used. Now the advantages for the capacitance voltage transformers are: it is simple and easy to design. It can be used both as a voltage measuring device for meter and reeling purpose, and also as a coupling condenser for power line carrier communication and relaying. Frequency dependent voltages, independent voltage distribution along elements as against conventional magnetic potential transformers, which require additional insulation design against surges. It can provide isolation between high voltage terminals and low voltage metering. So these are 4 advantages for the CVT. Now its disadvantages: the voltage ratio is susceptible to temperature variation. Problem of inducing ferro resonance in the power system. So these are certain disadvantages for the capacitance potential dividers and capacitance voltage transformers. Now we'll talk about potential transformers of magnetic type. In the magnetic type potential transformers, they are not as simply just as a transformer. The magnetic potential transformer are the oldest devices for AC measurement. It is nothing but we are magnetically we are reducing the voltage to measure. They are simple in construction and can be designed for any voltage. For very high voltage, cascading of the transformers is possible. So if you have very high voltage, you can cascade one transformer to the other, so that at the end you get a much more easily measurable voltage value, right? These devices suffer from the ratio and phase angle errors caused by the magnetizing and leakage impedance of the transformer windings. So this is one of the issue there, that because of this magnetizing and leakage impedance, there will be a phase angle and the ratio error will be present. The errors are compensated by adjusting turns ratio with a tapping on high voltage side under load condition. Potential transformer PT do not permit fast rising transient or high frequency voltage along with normal supply frequency, but harmonic voltages are usually measured with sufficient accuracy. With high voltage testing transformer, no separate potential transformer is used, but a potential transformer winding incorporated with high voltage winding of the testing transformer. This is one more variation, is called the electrostatic voltmeter for measurement of AC voltages. This is the electrostatic voltmeter.